Hello guys, welcome back to my channel DP Design, and in this video I am going to teach you how to do a CFD simulation of the drone. As you can see in the video, we have done one iteration on the drone by rotating the propeller at a particular RPM, right? So whatever force is required to uplift the drone, you can perform the simulation for that, and what is the flow pattern, how the air is behaving around the drone, right? So you can also animate that the flow pattern, and as you can see how the flow is behaving over here by rotating this propellers, or you can say the rotors. So this is one basic CFD simulation we will perform in this video. And yeah, so we will start from the scratch, and let's start. So before continuing, I will just close this result. Okay, so we have one drone. Okay, for the drone we have to do some CAD preparations. So we have to make rotating regions over these propellers so that you can give them input RPMs. So let's say we will start with the basic first. So as you can see, we have parts over there. This is the assembly where you can rotate the parts like that. Okay. So yeah, you can say this is the angle. Okay, you can change. So now what we will do, we have created rotating regions. How to create the rotating regions, I will show you for the one part. Let's say if you want to create for this rotor, okay, so this rotor is this one, and this is the reference plane for that. So what I'm going to do, I'm just going to perform the new part in the I want to create the new part in top down assembly. So what I will do, I will just create the new part and I will click it here. Okay, so as you can see, the part has been created. Now you can edit this part, go to the edit part, and yes, from that you can select the reference plane for that propeller, and you can perform the, as you can see, I will make one pattern over this, and you can just click revolve. Okay, so it will create the rotating region. So just like that, you can create more rotating regions, and you can copy those, and you can assemble in the coverage area whatever your propeller shaft is having. So if I am transparency apply, okay, I'm doing on this part. So as you can see, my rotating region is covering my whole propeller with the shaft, some amount of shaft. Okay, so you can also give the shaft as a rotating as well, but for now I'm just covering the propeller only. So as you can see, my three parts are already hidden, which is the similar to this rotating region which I have copied from this part. Now I will give the transparency to all the parts. Now we will move on to the CFD portion. So in the CFD portion, you can just go to the flow simulation, or if you are not having the flow simulation active, so what you can do, you can just go to the add-ins, and in the add-ins you can just select the flow simulation on, just like that. And if you want to run it as a start program, so you can just click on it. It will take a 2 seconds load time, extra load time to open the SolidWorks, right? So for now I have clicked the OK. Also you can go to the SolidWorks settings and click on the SolidWorks Flow Simulation. Okay, so yeah, now this is my solved results. Okay, these are my inputs I have given. So for that, what you have to do, okay, we will start from the basics of the CFD portion. So I'm not going to work in this existing project because it will not clear your doubts. So I will start with the first. So you have to save your project first, I will save the external. Okay, no problem. Path can be changed. I can save the internal as well. No problem. What I can do, I will just select the wizard, which will create a new project. Okay, so you can just give the project name as a drone CFD. Okay, and whatever configuration you have created, like many designs in one part you have created, so you can just perform in that particular configuration only. So I am using my default configuration for now. So if you have any comments or if you want to write down any description on that, so you can write down in the comment section. Now in the unit system, I will use the SI. Okay, international standard I will use. And if you want to change any unit from particular parameter, so you can just click, and whatever you want, you can select that. Also, you can customize your unit as well according to your formula, right? And also you can just select your custom package of the units. For now, I'm just select the SI unit, and okay. Now we are in the main portion, which is the analysis type. Now fluid flow, okay, that's what we going to do. Conduction we don't need for now because there is no heat I am applying on it, or no thermal properties I have given. So there is no heat conduction I want. And next one is a time dependent, which will take a lot of time, which you can call as a transient simulation. It will take time, so I will avoid time dependent simulation. And in gravity, I am not touching this portion for now. If you want to apply the gravity, you can just go to that section and apply the whatever XYZ component, okay, according to your axis. Now in the rotation, as you can see, my rotation region has been created, so you have to apply the rotation. So you have to check on it, rotation, and here there will be three options. First one is a global rotating, which is not related to our particular simulation. Second one is a local region in a sliding. So in the sliding, that is related to only transient simulation, which will give a more accurate results. But in the steady simulation, averaging local region will be better. Okay, so whenever you are going to do a steady simulation, CFD simulation, so you have to select the averaging, and if you are going to do a transient simulation, sliding will be more better for your analysis. Okay, so I am selecting the averaging. Now analysis type external, obviously yes, not an internal type. It is not enclosed. And geometry recognition CAD boolean, okay. Exclude cavities without condition, untick. Exclude internal space, untick. Okay, so I'm done with the analysis type. Next, I'm going to select the gases or whatever I want. Okay, in the gaseous form, I want only air to be performed in the simulation, so it will be only my project fluid. And in the flow characteristic, you have to select the laminar and turbulent both. If you select the turbulent only, there will be no issue because flow will be turbulent only in this kind of analysis. If you select the laminar, then you will get wrong results, right? Humidity, I don't want to add for now. If you check the humidity, you can just input the value for that. Now default wall thermal condition, this is the adiabatic wall. I am not going to do any thermal simulation. And roughness, I don't have values for now, but if you have a roughness value, then it will be better to input the value for better results. Okay, now in the thermodynamic parameters, my pressure and temperature, I will keep it as it is. Temperature will be same, and pressure, potential, gravity check. Pressure, potential, rotation, okay, it is checked only. If you are doing a rotating region simulation, then you must tick that portion. And in the velocity parameters, there is no external flow is going on like this, or right. So for now, I'm not going to add any velocity values in a particular direction. relative to rotating frame. Okay, yes. And in the turbulence parameter, okay, turbulence intensity and length, I will I will keep it as it is. Okay. So I'm done with my ambient and initial conditions, and also you can check the coordination system. Okay, so I am finished. Now, as you can see, my computational domain has been created automatically. But if you want a less region to slow down or sorry, I mean reduce the timeline for the simulation, so you can just make it a bit smaller. But for this kind of simulation, if you make a bigger computational domain, it will be better for watching the effects of flow. Now I will hide this computational domain because it will create a confusion for selection. Now in the rotating region, we have to give the particular RPMs to these propellers. So what you will do, you have to select the rotating region and select the rotating region parts. First I have to see in which direction I have to give the rotation. So I have to give the this in this direction. So what I will do, I will just click it as a clockwise. Okay, so okay, it is in a wrong side, so I have to give the minus value. So minus 5000 RPM I am giving just for a reference. Okay, you can just input your values. If I click it OK, as you can see, angular velocity has been applied. Okay, the same condition you have to give to the every rotation region. Like I'm just copying this value, so I don't have to put every time. Now in the rotating region, this will be also in the same direction. Okay, in the third one, okay, in the same direction. Okay, done. In fourth one also. Okay, so I'm done with my rotating region. Now let's come to the outputs of this simulation. So whatever you need from this simulation, you can just go to the goals. You can just go to the global goals and select the total forces which you have to calculate in the x direction or y direction. Okay, so in the y direction, your thrust will be calculated. So you can just click on it. Okay, and whatever you want, like a torque you want on this propellers, how much force it is coming throughout the flow. So you can just click on these parameters and you can get it as a output value, right? So there is no confusion in this parameter. So if you want any particular region to for having the output parameters, like I want to calculate the particular force on this fin, so what you can do, you can just go to the goals and you can select the surface parameters, and you can select the surfaces, and you can just go to the force values or normal force value. Normal will be perpendicular force value, and you can just select the force value for overall force value, right? And you can also tick the create goal for each surface, so it will calculate individually. So we are done with our parameters, and if you have any equations, like if you want to calculate overall upthrust values, so you can just input your expressions, which will be explained in upcoming videos in details. Okay, so for now we are done with that. And also, if you want to create the mesh, so you can just go to the basic mesh. Okay, it is very poor, by the way. So what you can do, you can just go to the global mesh and you can refine the value level of initial mesh, and also okay, and you can just create the mesh. Okay, so it will run accordingly. So my simulation has been started actually, but I will close that because it will take a lot of time. And okay, now let it close for now. It got stuck, I think. Okay, so it is closed. Do you want to wait it completely? Okay, no, I don't want. No. Okay, now I will go to my project one, which is my calculated, and I have computed the results. So what you can do, if you want to see your results, I will just hide this rotating regions because I don't need it now. Now, if you want to measure the velocity, the pressure on these surfaces, so what you can do, you can just go to the surface plot and select the surfaces you want. And you can just go to the velocity and click the OK, right? So somehow I have moved my cursor like that, so it is showing, right? But no problem at all. I have to increase the, I think 20. Now you can see the changes. You want a 30, you have to change the scale to visualize your results. Okay, in the cut plots, you can also see the velocity contour, and also if it is not visible, so what you can do, you can just go to the cut plot and you can click on the iso lines, turn off the contour, and keep up this high velocity, and okay. So as you can see, the major changes area will be identified, right? So also here you have to change the scale accordingly, so it will be more visible for your results. So this is just a static simulation I have done, a steady simulation. In the next video, I will do the transient simulation, which will take a more computational time, but more accurate. And also you can see this propeller rotating. And I have created, okay, I forgot to explain the flow trajectory. So what you can do, if you want to visualize your flow trajectories, so what you can do, you can just click the insert, and whatever surfaces you want, like if I want my flow to be visualized on these two surfaces only, and I will create the starting points up to 300, and it is as a lines. Okay, and I will select OK. Then it will show something like that. Whatever flow is touching over the surface, it will create the trajectories, so you can just visualize that. And also it will be better if you select the dynamic trajectories, because that will be better actually for visualizing your flow pattern. If you play, as you can see how it is playing. Okay, better if you select the surface of your rotating region, it will be better for your flow visualization. And this is some animation controls, dynamic trajectories. So yeah, so we are done with the CFD simulation and also the output. If you want to check your these forces which you have given in the goals, so whenever you calculate, it will come directly over to this goal plots, and in the goal plot you can just directly export to the Excel file, which will help you to calculate the upthrust values for the drones at a particular RPM, right? So this was the basic CFD simulation of the drone. In the upcoming video, we will do the transient simulation, and we will use the sliding local region. And also you can visualize the rotating propellers with the CFD in SolidWorks. Okay, so yeah, that's all for the video. If you really enjoy the video, like, share and subscribe. Keep sharing, keep learning, and help us to grow more and help us to spread the knowledge. Okay, so signing off, DP Design.